think of what we did today. Oh boy. So we're talking. We need to talk about reciprocals first. All right. Let's talk about reciprocals. The reciprocal of a number is a value that. Let me give you an example. Reciprocal of 3 is a number that when I multiply times 3, it gives me 1. So what can I multiply times 3 to 1? It would be 1/3. The reciprocal of 3 is 1/3. If you multiply this out, let me put, you're going to say, what's a whole number in a fraction? Let's put this over 1. 3 times 1 on the top is 3. At the bottom, 1 times 3 is 3. And what's 3 divided by 3? It equals 1. So the reciprocal, so a number and its reciprocal, when you multiply, the product will always be 1. Let's try a different number. 2/3. What can I multiply 2/3 by to give me 1? I can multiply it by its reciprocal. The reciprocal of 2/3 will be 3/2. 2 times 3 is 6. 3 times 2 is 6. And 6/6 equals 1. I don't know. Try another one. 7/5. What's the reciprocal of 7/5? Well, it'd be 5/7. 7 times 5 is 35. 5 times 7 is 35. And 35 divided by 5 is 1. So a number and its reciprocal, when multiplied, will always result into 1. So that's reciprocal. Now comes where have we seen? Well, we have seen this before. So let me take an example, maybe not a triangle. Let me just stick to rectangles. Here's a one rectangle, and here is another rectangle that was scaled up. So let's make them simple numbers, 2 and 4, and then let's make this 10 and 20. All right, so if I asked you, what was the scale factor used? Well, you're going to say that's easy. 10 divided by 2. So I multiply 2 times 5 to get 10. Remember, we're scaling up. And then 4 times that same scale factor, 5 equals 20. So the scale factor here was 5. Now, what if I did this? What if I took that same small rectangle and instead I started this way? I had a rectangle where this was 20 and this was 10, and I scaled it down. Well, how did the 10 become 2 and how did the 20 become 4? I know, you're going to say divide by 5, which is correct, right? But I want you to start thinking in terms of multiplication. So notice, remember what division is. Division is the same as multiplying by the reciprocal. So what does that mean? So instead of saying divided by 5, right, we can say, well, 20 was multiplied by the reciprocal of 5, which is 1/5. And 10 was multiplied, and 10 was multiplied by 1/5 to get 2. So if you take your calculator, or if you think about it, if you had 20 bucks and I said, give me 1/5 of your money, you would give me $4. If you had $10 and I said, give me 1/5 of your money, you would give me $2. So it's the same way. So I need you to really, really think about reciprocals today, okay? And that's very easy because once you know this number here going in one direction, you know that the other direction is going to be its reciprocal, okay? Give me another example, 4 and 7, this is, I don't know, 10 and, just make this 17.5, okay? And I'm going to get rid of these two. And I said, hey, well, how do we go this way? How do we scale up? What do we multiply by to get 10? We're scaling up. So you would divide 10 divided by 4, and you say, hey, that was easy, times 2.5. And then the top, times 2.5, right, to scale up. But what if it was the other way around? And I said, hey, we're starting with this rectangle. I don't know why I deleted the original ones. And we're going to scale down. So the 10 became 4, and the 17.5 becomes 7. So remember, if they are similar, right, if they're scaled copies of each other, we multiply all the dimensions by the same scale factor. And what do we multiply by? We're not going to say 2.5. In actuality, I messed up here. I actually wanted to say, well, 5/2, which is 2.5. This is 5/2, which is 2.5, and this is times. So the reciprocal of 5/2 would What if you did it was 2.5? If you actually did it was 2.5, let me go back. Right, so let's say you said times 2.5 going, scaling it up, right? What would be the reciprocal of 2.5? Well, 2.5, sorry, 2.5, right? You could have written that as a fraction, right, which is 25 over 10, right, the same thing. And if you simplify 25 over 10, divide that by 5, divide that by 5, you get 5 over 2. And so that's the same thing as multiplying by 5 over 2 times 5 over 2. And then you would know that coming this way, you multiply by 2/5 and multiply that by 2/5. We got to start thinking of fractions as well. Okay, so that's basically it. So if you can understand the reciprocal, right, once you have one of the numbers going one direction, the other direction is going to be its reciprocal. Let's see if I make more sense with this guy here. Where is it? Not this one. This one. Okay, I'm gonna skip all that. Ugh. All right, so let's see what this says. Complete the table. What in the world? And determine the constant proportionality. Complete the table and then determine the constant proportionality. So notice that these two tables compare length in centimeters with length in millimeters, and this one is the same thing except that it's backwards. So how did the 4 become a 10? What's the constant proportionality here? That one should be pretty easy. Times 10, times 10, times 10. Right? Times 10, times 10. So this would be 120, this would be 500, and this would be 884.9. What if we switch them around? Now, we're going from millimeters to centimeters, so we're going this way. I wish that they had written the table. Oh, they did. So think about this. To go from 4 to 40 is times 10. To go to 20 from 25 using the same relationship, right, the same table, to go to 25 to 2.5, is it times 10? Is 25 times 10 2.5? No, it's not. So because we know that going this way, right, is times 10, going the opposite way, going from millimeters to centimeters in this sense, in this case, it's not going to be the 10, but the reciprocal of 10, which is 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. So imagine 240, and I broke it up in 10 pieces, and I took one. What did I take? I took 24. You had $4, and I took 1/10, where you had $4 and you broke it up in 10 pieces. I took 40 cents. If you had $699.10 and I took 1/10 from you, I would have taken $69.91. Okay, so if this is the same relationship, right? Same numbers, same table, right? We can say that going one way, the constant proportionality is 10, and going the other way, the constant proportionality is 1 over 10. Now, here is the important part. Oh no. Okay, here's the important part today. The important part today is, let me just write this again, times 10, times 10, times 10, times 10. This one was times the reciprocal 1 over 10, because we're going the other direction. We're going from millimeters to centimeters, times 1 over 10, times 1 over 10. So the equation here, right? Oh no, not again. Sorry, you just lose it. Okay. So the equation here, think about what am I doing to this column? Let's call this the x and y column. Right, so this is 120, this was 500, and this was 884.90. So how am I getting y? What do I have to do to find the length in millimeters? Well, in order to get y, right, what am I doing? I'm multiplying 10 times who? times all these guys here, the 4, the 12, the 50, and 88.49, and all of them are called, in this case, x. Right, so if I multiply 10 times any number in the x column, I get y. Here, and again, if I'm going to keep this the same, this is y and this is x. So here I'm not interested in getting y, I'm interested in getting x. Let me put that here for a second. Right, so how do I get x? In order to get x, and here's that difference, right? In order to get x, what am I doing? I'm multiplying 1 over 10 times who? Times all these guys in this column. What are those numbers called? They're called y. Look at the equation. They're very, very similar. Here, I'm asking you, find y. Find the total y. Here, I'm asking you to find x. That's the difference. Okay? I hope. All right, how are the two constants of proportionality related to each other? So one constant of proportionality was 10, the other one was 1 over 10. What are these two? They are reciprocals. Okay. Let's see. Molly and Hikari are converting measurements between inches and feet. So we know what we can do. We can create a table just to make it so inches and feet for the relation between inches and feet. So we know that 12 inches is 1. So 12 inches is 1 feet. Okay. Let me not create a table. The relationship between inches and feet is inches and feet is 12. Hikari says it's 1 over 12. Who is correct? So they said a relationship between an order matters here, between inches and feet. Okay, so let me write this as a fraction, inches and feet. So if you write this as a fraction, we know that there are 12 inches in 1 foot, right? So this relationship is at 12 inches for every foot. Is it this guy or is it this guy? Because this one says 1 over 12 says 1 inch for every feet. The order in which they want us to write is inches to feet. So the only one that's correct in this case is, what is this guy's name? Is Amoli. Because 12 over 1 actually simplifies to just 12. Yeah? Oh boy. 1 second, guys. My battery's dying. 1 second. Oh, yeah. All right, so this is a tricky question. Okay, tricky question. Let's set up a table. Let's call this inches and feet, and then feet and inches. It really depends on how it was set up. So if you look at it this way, there are 12 inches in 1 foot. Okay, I should change that to foot. All right, tricky question, I think. So inches, foot, feet, feet, and then feet to inches. So two ways of looking at it. So if this is x and this is y, and instead of x and y, I'm going to write, well, feet is already y, right? So we're going to keep inches as x, right? Keeping the same, just switching the sides here. So we know that 12 inches is 1 foot. So we can write that for every 12 inches, right, there's 1 foot. And if I, the constant proportionality here, or let's go to 5, the next question. So this one says, a recipe for granola calls for 5 2 cups of rolled oats and 3/4 cups of shredded coconut. So let me add a column here, or a better column. And it says that if I have 5/2, or 2.5 cups, I'm going to keep it as a fraction. 5/2, I need 3/4 cups. Okay, so what is the constant proportionality going this way? Right, for every 1 cup, what is it that I need? So how do I find the constant proportionality? Remember, to find the cup, and let's call this x and y. To find the constant proportionality, right, for every 1 cup, I'm going to have to divide 3/4 fraction divided by 5/2. Now remember 6th grade, how you divided this? 3/4 times the reciprocal of 5/2, which is 2/5. And we get, I can simplify before I multiply, but I'll do this. The final answer is 3/10. So it's times, right, so let me erase this, times 3/10, times 3/10, times 3/10, times 3/10. So if I have, and let me just confirm, 5, that's 15, 2, yeah, that right works out. So if I have 1 cup of rolled oats, I would need 3/10 cup of coconut cups. This would be 3/2, And this would be, what's 12 times 3 over 10? Simplifying, we get a 5 and a 4 will be 12 fifths. Okay, so what is the constant proportionality in this relationship? What does it represent? The constant proportionality, K, is 3 over 10. What does it stand for? Well, it means that for every 1 cup of oats, you get 3/10 cup of coconut. What's the other constant proportionality? Well, the other constant proportionality is, what if I had this number, for example? So let me extend here. What if I had to go this direction? So let's say I had, I don't know, I'm making this up. Let's say I had five cups of coconut cups, and I wanted to find the oats. And this was, what would I do? Would I still multiply by 3 over 10? No, right? Remember, we're going the other way, so we're going to multiply by the reciprocal. What's the reciprocal of 3 over 10? You multiply by 10 over 3. So the other constant proportionality is 10 over 3. What does it represent? Well, it represents, so the constant proportionality will be going that way. So let me add a 1 here. It will be 1 times 10 over 3. So any number going from coconut to oats will be times 10 over 3. So that means that for every 1 cup of coconuts, we get 10 over 3 cups of oats. And that's what that 10/3, the other constant proportionality, stands for. T represents the number of cups of oats, and C represents the number of cups. Write 2 equations. Okay, so we're going to write 2 equations. So maybe I should have done 2. Let me erase this here. So one is going the other way, so I'm going to quickly make another table over here. Okay. Right, and this one we know that, let's say you had 1 cup of coconut. How would I find x? You would multiply by 10 over 3 times 10 over 3. Right, so we're going this way, that direction here. Right. So on the first table, you're multiplying x times the constant proportionality to get y. So the equation for the first one, for this table right here, right? Write 2 equations representing the relationship between t and c. So who's t? T is the oats. Mine's t oats. All right, so t is the oats. All right, so this is t, the oats, and then c for coconut. So let's do the first table. So the first table says, if I want to find out how many cups of coconuts, represented by the letter C, I have to multiply 3 over 10 times 3 over 10 times 3 over. What am I multiplying 3 over 10? All the oats. And what are the oats called? The letter T. In the second table, where you have the coconut, and you want to find the oats, so it's reversed, right? So to find the cups of oats that you need, and oats in this case is represented by the letter the coconut is represented by the letter C, and this is represented by the letter T. So to find the number of cups of oats, T, that you need, what are we doing here? We're multiplying all the y values by what? 10 over 3 times y. Look at these 2 equations here and here. Why do they call it y? C. So, I mean, in its simplest terms, right? Here, I'm trying to find C. Here, I'm trying to find T. So you reverse the letters, and you use the reciprocal of the first one. Right, so the first equation you use 3 over 10, the second equation you use 10 over 3. Okay. Which equation has a constant proportionality equal to 5? Okay. Remember, constant proportionality, it's like this, right? So here's my constant proportionality, the number that we multiply all the x values with. So which of these has a constant proportionality of 5? In order to find that, we got to change this equation so that it looks like this. Each of them, we're going to change it so they all look like this. But we got to do a few things in order for them to look that way. So the first equation, let's get rid of this 5 here. So I'm going to divide this by 5 and divide this by 5. 5 divided by 5 goes away. I'm left with y. On the other side, 5 divided by 5 is 1, and 1 times x is x. But does that have a constant proportionality equal to 5? By the way, do you know what number is in front of that x right now? The coefficient in front of the x? There's always an invisible 1 here. We don't write it, but there's a 1. So that's not it because we want it to be 5. Second one, divide by 5, divide by 5. So y is all by itself, and then 15 divided by 5 is 3. And we get 3 times x. That's also not the 1. Third one, divide by 3, divide by 3. 3 divided by 3 is 1, 1 times y is y, and then 5 over 3 is just 5 over 3. Just leave it like that. Is the constant proportionality 5? No, it's 5 over 3. Last one, divide by 3, divide by 3. 3 divided by 3 is just y, and 15 divided by 3 is 5. And this is the equation that has the constant proportionality that equals to 5. We have some additional practice here. And over here, quadrilateral B is a copy of quadrilateral A. The table shows their side length. What is the constant proportionality that gives the side length of quadrilateral B given corresponding side? What the heck? That gives the side length quadrilateral B given the corresponding side length quadrilateral A. So they're asking for this, right? Given this, right? What's the constant proportionality that was used here? Okay. What in the world? There's something wrong here. Yeah, there's something wrong. Give me a second. Let me look at this. Yeah, there's something wrong with this last one. Let me just give me a second. 10.4 times 4? No. What did they mess up here? So we need to ignore this one because there's no way this works. So let's get rid of that one. Alright, so let's do this one. So we need to find, so they're asking, what's the constant proportionality? So how are we getting from this to that? What's the constant proportionality used here? What's the unit rate? Well, to find that, we're going to divide 10 divided by 2.5, and obviously we get 4. So the constant proportionality is times 4, times 4, times 4, except for this one, I have no idea what they did. It's incorrect. So everything else works out. So the constant proportionality that takes quadrilateral A to quadrilateral B is 4. But what is the constant proportionality? What if you did it the other way? Going from B to A. It's 10 times 4, 2.5? No, it'd be 10 times, and let me erase this. Right, so going the other way, so if we're going this way, we're going to be multiplying what's the reciprocal 4? It's 1 over 4 times 1 over 4 times 1 over 4. And it makes sense, right? So 24 times, what's 1/4 of 24? 6. What's 1/4 of 10? 2.5. What's 1/4 of 17? 19.5. Right, so the other constant proportionality is 1/4. Okay, so okay, complete each sentence. Complete the table with equivalent distances. Okay. So let's look over here. Let's fill in the table first. So let's pick up, well, we can't do anything. We gotta look here. It's the only place that has two values. So let's go this way because that's the easy way. 1 times 3 is 3. So this would be times 3. So everything is going that way, and I'll put an arrow going that way. 7 times 3 is 21. And then what if I went this way now? Change colors. So if it was times 3 going this way, what about going that way? Which is the direction these two have to go. Well, it wouldn't be times 3, but it would be times, what's the reciprocal of 3? Times 1/3. And this would be times 1/3. What's 1 times 1/3 would be 1/3. And what's 30 times 1/3, which would be 10. So multiplying the distance given in feet, so if you had feet by 1/3, if you multiply feet to go that direction, and you want to get to yard, you're going to multiply by 1/3. What if you had the yards and you want to find the feet? You would multiply it by 3. Okay. Airport in Mexico City changed money. There we go. That's a nice question. So let's use this relationship here. Let's go this way from dollars to pesos. So if I wanted to find the constant proportionality, what did I multiply the dollars by to get 6,000? You would divide 6,000 times 300, 60 times 30, and the constant proportionality is 20. So it would be times 20. This would be times 20. 1 times 20 gives you 20 pesos. If you have $500, multiply that 20, you get 1,000 pesos. But what if you had 1 peso? That's different, right? So we're going this way. We know that changing from dollars to peso was times 20, so going the opposite way would not be, it would be multiplied by the reciprocal, which is 1/20. All right, so 1 peso times 1/20 would be 1/20th of a dollar, and 1/20th of a dollar, you would actually get 5 cents. Okay. Okay, so how many Mexican pesos are equivalent to $1? So every dollar, for every $1, 1 US dollar equals 20 pesos. How many Mexican pesos are equivalent to $500? Well, if you have $500, so it's $1,000, 1,000 pesos. How many US coins are equivalent to 1 Mexican peso? So if you had 5 cents, and you took it to Mexico, you would get 1 peso. Okay? I think money makes it a little bit easier to understand. A cell phone company offers a data plan, 3, 4, 5 gigs, storage a month. 1 gigabyte is equivalent to 1,000 megabytes. So we can add a column here, which is what you should always do. It says that 1 gigabyte is equal to 1,000 megabytes. Find the constant proportionality. Well, going this way, what is it times? It's times 1,000. So there's like constant proportionality right here, because here times 1,000, 3,000, times 1,000, 4,000, times 1,000, 5,000. So what was the constant proportionality? 1,000. So the table below shows the value in gigabytes equivalent to the given amounts of data in megabytes. What's the constant proportionality? So this one we're going backwards, right? So this would be, so remember we went from gigabytes to megabytes. So what if you went from megabytes to gigabytes? Well, the constant proportionality was 1,000, so what's the reciprocal? 1/1,000. So this time around we can multiply that by 1/1,000 times 1/1,000 times 1/1,000. Okay, so 3,000 times, sorry, 3,000 times 1/1,000 is going to be 3. Sorry, 2. 2 times 1/1,000 is just going to be 2. So 2 gigabytes, 1 gigabyte, and 0.5 gigabyte. Okay. Constant proportionality, yeah, we found that it's 1 over 1,000. What's the relationship between the two constants? So one was 1,000. Right, one constant proportionality was 1,000. The other one was 1 over 1,000. What are these two called? They're called reciprocals. Hannah and Helena are comparing a painting to a scale drawing of a painting. Hannah realizes the side length of the scale drawing are 1/4 of the length of the corresponding side. The actual painting concludes the scale factor is 1/4. Helena says 1/4 is also one of the constant proportionality. She's correct. So let's draw. I don't know. Let's call this 2 and 4. Let's pick easy number. A painting, the scale drawing of the painting, and realize that the side lengths of the scale drawing here and that are 1/4 of the actual. So this is 1/4 of this, right? So if you had a scale drawing going this way, we multiplied that by 1/4, multiplied that by 1/4. So whatever you had here was multiplied by 1/4. But if you want to actually find the real, the actual drawing, you would not multiply it by 1/4, but multiply them by the reciprocal. So going this way, which I'm going to change colors, right? To go backward to the original, you multiply by 4, and you multiply the 2 by 4. So the actual measurements of the picture, 2 times 4, which make this 8, and 4 times 4, which make this 16. These numbers, I just made it up, so you understand what's going on here. So Hannah realized that the side lengths of the scale drawing 1/4 of in the actual painting, concludes that scale factor is 1/4. And then it says 1/4 is also one of the constant proportionality. Is she correct? Well, I actually, so depends here. Yes, the scale factor is 1/4, and it's also the constant proportionality. Okay, because to go from the scale drawing is 1/4. So this is the original. The original became a smaller one. And what was the scale factor used? The scale factor used was 1/4. And obviously, if the scale factor is 1/4, that is also our constant of proportionality. Okay. And the other constant proportionality would be the reciprocal of 1/4, which is 4. Last question. Okay. Lane determined the area of 3 squares. So you had 3 squares. 3 by 3, 5 by 5, and a 7 by 7. Okay. She said there's a proportional relationship between the side lengths of the squares and their corresponding areas. Do you agree? What? She said there's a proportional relationship between the side length of the squares and the, so this, what's the area here? The area of this guy is 9. The area of this guy is 15. And the area of this guy is, sorry, not 15, 25. And this area of this guy is 49. Is there a relationship between the side length and their corresponding areas? Is there something I can multiply so let me write this like this, maybe it's easier. This is a side and this is the area. Right, so when the side is 3, the area is 9. When the side is 5, the area is 25. When the side is 7, the area is 49. So we're looking for constant proportionality. Is there a same number that I can use? Because this is the constant proportionality, right? 3 times a constant proportionality is 3. if the constant proportion is 3, this should be 3, this should be 3. So is there a constant proportionality? Is there a number that I can multiply the side, all the sides, to get the area? The same number, by the way, right? Because that would be, hence the constant proportionality. Do we have that? No, we don't. There is no such number, right? So this one, the answer is no. There's no number, same number that I can multiply the 3, the 5, the 7 by to get the area. Okay. I think that's it. Let me clear this.